Hello, welcome to IB Math with Mr. Adil, and today we are going to consider arithmetic series as a logical continuation of the topic of arithmetic sequence. The general term formula looks like this, and I hope you remember this formula from the previous video. If you didn't see and want to understand how the arithmetic sequence works, please visit the previous video about the sequence. Okay. In this video, we are going to first explain how the formula of arithmetic series is deduced. The series means that we should add all terms of the sequence together. So let's start with a very basic example. Let's add up together the numbers from 1 to 10, from 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 9 plus 10. Okay, so if we will calculate it one by one, from the left to the right, it takes time, yeah? But what is the fastest way? The fastest way is to find the pairs. If we look at the first term and the last term, we will see that it is the same as the second term and then the term before the last one. So 2 and 9. The next pairs is 3 and 8. And as you see, all these terms give us the same value together. So 7 plus 4 is 11 and 5 plus 6 is also 11. Okay, so how we can write it quickly? So first of all, we have to add together 1 plus 10, which is 11, yeah, 1 plus 10, for example, and multiply by the number of pairs. For this case, number of pairs is 5. So this sum is equal to 55. Okay, S of 10 terms. And now, let's talk about the UN now. UN, U1 plus U2 plus U3 plus and so on, plus UN minus 1. This is almost the last term, and the last term is UN. And now we're going to combine again the pairs. So this pair give us UN, U1 plus UN, right? And now we should multiply by the number of pairs. If the total number of the terms is n, then the number of pairs is exactly half, so n over 2. So sum of n terms is equal to this formula. So this formula is going to be in a formula booklet, so you'll find it in formula booklet. It is one formula, and another formula which is more beneficial and more useful is obtained from the general term formula. So if we will plug inside the UN our general term formula, we will have another formula, and let's do that together. So let's derive the formula of arithmetic series. So n over 2, and instead of U1, I'm going to plug the general term formula, U1 plus n minus 1 d. Yeah, let me color code. And after simplification, the final formula will look like n over 2 u1 plus 2u1, 2u1 plus n minus 1 d. This formula also presented in formula booklet, and it is more useful because most of the time in the problems given the u1, d and n only. Okay, so it's not all the time we can find un straightforward. Sometimes it is quite challenging and unnecessary. That is why this formula, the last formula, is most appropriate most of the time. I would say like 90% of the time of the questions is about the last formula of arithmetic series. Now let's have a look how this formula will work in terms of the context of the problems. So question 1. An arithmetic sequence has the first term 5, the common difference is -2, and find the sum for the first 10 terms. Okay, the first term is 1. Let's just convert to mathematical language. U1 is equal to 5, and common difference is d, is -2. Okay, and we should find the sum of 10 terms. If we will plug everything inside the formula, we will get S10 is equal to n divided by 2, U1, which is 5, 2u1. Yeah, let's use this formula. So let me use the colors to show how it works. So u1 is this one, yeah, so u1 is this one, and so 2 times 5 plus n minus 1, it is 10 minus 1, and common difference -2. Okay, -2. So let's divide. 2 plus 5 is 10. 9 times negative 2. Okay, so let's finish our calculation. So 10 minus 18 and 5 times negative 8 is equal to negative 40. Negative 40. Okay, so the sum of the 10 terms is negative 40. It actually makes sense, because if we want to expand our sequence to see how the terms looks like inside the sequence, we will see the next picture. So we have 5 as the first term, then 3, then 1, minus 1, minus 3, minus 5, minus 7, and so on. If we will add up together all the terms, we will have negative 4 as a sum of the 10 terms. Okay, the next example is about the arithmetic sequence with the first term and the last term. So in this case, we are going to use straightforward the formula that we obtained first. So u1 plus un. Okay, so this is u1, this is un, the last term. The last term means un, okay? Un is 1000 and u1 is 10. So there are 30 terms, it's actually n, okay? And now let's plug all together, all the numbers in our formula. So 10 plus 1000, okay. So what we can do, just 15 times 1010. Okay, you can use calculator, it's not the matter here. The key point is to able to find this sum. So 5 0 5, and here, yeah, I will use very traditional style of the calculation. So it is 15,150. This is a final answer. Sn is equal to 15,150. This is a final answer for this question. Okay, and let's consider the last question about the arithmetic sequence. So this is about the arithmetic series. This is a sequence not given. So you see, we have to obtain all the parameters by ourselves. So here u1 is equal to 3. I hope it is obvious for you, because this number appears first in the sequence. And the difference, you see that our sequence is increasing sequence. That is why we have to add together 4 for all the previous terms. So d is equal to 4, and it says that sum is equal to the sum of n terms is equal to, yeah, if we will connect, we will see that it is about Sn is equal to 465. Okay, now let's use the formula. So again, given the u1 and d, that is why we're using the second formula. Let me just write it one more time here. Yeah. Okay, and now let's expand. Let's, instead of Sn, write everything that we have. N over 2 u1, so 2 times 3 plus n minus 1, and d is equal to 4. Okay, and now everything is equal to 465. Now we have an equation. If we look carefully, it is quadratic equation. Okay, let's solve this quadratic equation. Let's simplify first. Let's everything multiply by 2, so n 6 plus n minus 1 times 4 multiplied by 465 by 2. Okay, let's open the bracket. 6n plus 4n squared minus 4n is equal to 930. Okay, now it's everything divisible by 2, so let's divide by 2. So 3n is equal to plus 2n squared. So it doesn't matter how you will solve. You can even use calculator. It's not a point here. The main idea is to understand how this formula of arithmetic series works. 2n squared plus n equals to 465. So 2n squared plus n minus 465 is equal to 0. Okay, so 465. So 465 is divisible by 3. So we can use denominator, for example, or you can solve in any other way you wish. Okay, and that's how you will get an answer. Okay, so for this case, the answer is going to be equal. Let's see, find the discriminant. 1 plus 4 times 2 times 465. Okay, and it is equal to, yeah. So the calculation is not so important here, but anyway, using the GDC, so and so on, yeah, we'll find that n is equal to 15. There will be 2n, and we are not counting negative n as an answer, because n must be positive, because it is number of terms. So it means that 15 terms of this sequence, so 15 terms of this sequence in the addition give us 465. Okay, this is the idea. Okay, please subscribe, write your answer, leave your reaction. See you in the next video. So in this lesson we have considered arithmetic series, considered 2 formulas, and several practice examples. See you in the next video. Have a nice day. Goodbye.